Today in Python, we'll be learning how to do simple projectile physics and make a game which simulates a cannonball being launched in an arc. In addition to giving us data on how that cannonball might travel, how far and high it will go. I'll show you the end result before we start. It's called shoot the castle. // We run the program, it gives us a little message. Click on screen to set the horizontal and vertical velocities of the cannonball. The program will then simulate, using Isaac Newton's kinematic equations, the trajectory of the cannonball. Simply that means you click to set how fast the ball goes, and it goes. So let's click more high than far across. This will give us more of a tall arc. The ball goes up, slows down, and then comes back, accelerating as it goes. We could try another tall arc like this. You'll see it starts off going fast, it loses speed as it goes up, comes almost to a stop, and then accelerates downward. We could also try a horizontal arc. You'll notice that in the terminal here, we're getting statistics about the cannonball. It tells us how many feet per second it's traveling in both directions. It tells us the maximum height, the time at maximum height, the maximum distance, and the maximum time. That's what we're going to do. Now we need to program it in Python. We're going to make a game which simulates firing a cannonball and the arc in which that cannonball will travel. To display the graphics for this game, we'll be using a game library called PyGame. To import that into Python, use import PyGame. Now we save and press F5 to run just to check that PyGame works. You'll probably get this message saying that PyGame doesn't work on your computer. You're going to need to install PyGame. Let's fast forward through that. Tick, 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 tick. Okay, so here's a version of Python that does have PyGame. This is the one we'll be developing with. It's different for every computer. You may need to download PyGame. Links will be in the description. So you can use idle for this, but I'm going to use a command line editor. Open up a file, shootthecastle.py, and we'll start by importing PyGame. Next, what do? Well, we need to know the mathematical equations used for simulating gravity. At every given point in time, for projectile motion, you're going to need to know how high the projectile is and how far across it is. There are two equations invented by Isaac Newton for doing this. I'm going to show you them. You don't need to copy this part, it's just for show. The equations are h of t equals -16 multiplied by t squared plus initial velocity times t plus initial height. What? Let's write them out. H of t is equal to -16t squared plus initial velocity which is called VO plus initial height, HO. So, how's this work? Well, we put in the time after the cannonball has been fired as t, and the function gives us how high the cannonball is at that point. So, let's try it out. Say that we have a cannonball which is fired at 5 feet per second, and we want to know how high it'll be 1 second in. We're going to do negative 16 times t squared, which would be 1 second times 1 second times 1 times 1 equals negative 16 plus the initial velocity multiplied by t. Let's add that in. Plus initial velocity of 5 feet per second multiplied by 1 second, which is the time we want to get the height for, at plus initial height, which is 0. Negative 11 feet, because the cannonball has already hit the ground. Now, this is the equation for how high the ball is at any given point in time. But we also need to know how far the ball has traveled. For that, we go to the age-old formula. Distance equals velocity multiplied by time. This is self-explanatory. If the ball starts out going 5 feet per second horizontally, then the distance it will have traveled after 5 seconds will be 5 times 5, or 25 feet. That's easy. Now we've done the math, let's do the programming. We're going to go back into idle or whatever editor you're using, and we'll start out by importing another part of PyGame. From pygame.locals import star. This imports all the stuff to do with keyboard and mouse in PyGame, which we'll need later. Then we do pygame.init. We're now calling a function from PyGame that gets it all going. Then we're going to print to the terminal a welcome message. Welcome to Shoot the Castle, a projectile physics simulator written in Python. Now we need to open a new window using PyGame. Window, our variable, equals pygame.display.setMode, double brackets, the width of the window in pixels, and the height of the window in pixels. I'm going to make the window 1,000 pixels wide, 500 pixels tall. Now, we have a window. Now we need to set the caption on that window. pygame.display.setCaption. And we're going to write Shoot the Castle, Projectile Physics. Now, we're going to write the game loop. What's a game loop? Well, it has to do with the way computer animation works. Much in the same way as a movie on film, computer animation works by showing a series of still images very fast so that it looks like you're getting a moving image. Which means that you need a loop which will constantly generate still images which are slightly different from one another. We'll use a while true loop which loops forever, and inside it we'll just say pass for now, which means do nothing. Now, save your file, however you do that in your editor, and run it. You'll get your window, 1000 pixels by 500 pixels, but not yet captioned. And in your terminal, you'll get the welcome message, welcome to shoot the castle. So we're good so far. Press Control-C to kill the program, and then go back into your editor. Now, we've noticed a problem with our game. When we ran it, we just saw the spinning beach ball of death on Mac, and we couldn't close the window. We need to handle what happens when the user tries to close the window. We're going to say, for event in pygame.event.get, which means for every event that just happened to the window, do something. If event.type equals quit, tabs pygame.quit, exit. Now I want to stress this very much. You see this spacing here in front of the line? It matters. This spacing determines what loop or what if clause any statement is part of. This spacing matters. If you get it wrong, your program will fail. Now, there's something else you have to do. Because computer animation is made up of many still frames, after you draw a frame, you have to show it to the user. So after this event handler, we're going to put pygame.display.flip to show everything. Save and run. So now you get a window called Shoot the Castle, Projectile Physics. It's all black because we haven't drawn anything yet. And we can X the window out successfully. Everything works. We even get a message in the console. Back into editing. Now, this black background doesn't look very nice. We need to background the image using, say, white for now. So we're going to use window.fill, double brackets, and then we input the color we want to fill the window with. In this case, it's white, which is represented by 255, 255, 255, double brackets. Save and run. This time we get a white window with title and we can exit out easily. That's progress. What next? Well, after your event.pygame.get, we actually need to draw a cannonball. What? How are we going to do that? Well, we'll start out by handling a mouse click. Because if you remember the way the game works, you click the mouse and the cannonball starts based on where you click the mouse. So we need to get a mouse click. Inside your event.pygame.get, say elif, else if, event.type equals mouse button up, which means the mouse was clicked. Then we're going to change the caption on the window to say you just fired the cannon. Let's try what we have so far. Save and run. Let's click the window. And our program crashes. Why? Because we mistyped the word caption. Let's fix that. Save and run. click, and the caption changes to "You just fired the cannon." Go back into your editor, and this time, when the window gets clicked, we need to set up the firing of a cannonball. First of all, we're going to want to read where the mouse was clicked. That's easy. We say mouse position equals pygame.mouse.getPos. Now, the x-coordinate of the mouse is going to be mouse pos 0, so we'll store that as mouse x equals mouse pos 0, mouse y equals mouse pos 1. What do we have now? We have two variables, mouse x and mouse y, which tell us where the mouse was clicked. These mouse x and mouse y, incidentally, are also going to be the velocities of the cannonball. Let's print them out. Print initial horizontal velocity is mouse x. Notice how we're using a plus sign here to add the variable mouse x to initial horizontal velocity. But that's not all we need to do. We need to convert mouse x into a string, aka a text variable. Now, let's make a notification for initial horizontal velocity. Save and run. We get a window which starts out saying, "Shoot the castle, projectile physics." If we click, we get an error because I spelled something wrong again. This is very common. Python has no spell check, and if you get something wrong, you get it wrong, and it'll just error out. Add an E there, save and run. We get the window. We click. It says, "You just fired the cannon." And if you take a look, it tells us initial horizontal velocity is 202, initial vertical velocity is 94. X out the window. We're done there. So, we now need to output some statistics. We need to work out how far this cannonball is going to go in total, and we need to work out how high it's going to go. This is where the math comes in. It's a bit hard to explain, but basically, the time at which the cannonball is highest, we'll call that time at apex, is equal to 0 minus mouse y divided by negative 32.0. Just type that in exactly. It'll give you the time at the very apex of the cannonball firing. Now that the important mathematical part of simulating a cannonball is done, I'm just going to breeze through the animation. We're going to define three variables, time, height, and distance, which respectively designate how long the cannonball has been in flight for, that would be time, how high the cannonball is, and how far the cannonball is from the cannon. In this animation loop, we'll first check whether anybody wants to close the window, and if they do, we quit. Then, if that is not true, we clear the window to white, and we calculate the height of the cannonball at the current time, using the height equation. Then we use d equals vt to calculate the current distance. Then we use pygame.draw.circle to draw the cannonball at the correct place. Then we show this to the user and wait a little bit using clock.tick to make sure the game doesn't run too fast. Then we make time go a little further on and we go around and recalculate. If distance gets past the edge of the screen or height gets past the edge of the screen, we break, which takes us out of this loop and back into this one. Let's try this out now. Save and run. By the way, this whole program with embellishments will be downloadable in the link in the video description below. So, our window starts out 1000 pixels by 500 pixels saying shoot the castle, projectile physics. We click to fire and we get a cannonball going in a nice arc. Watch slowly. The cannonball clearly arcs. It slows down as it gets to the apex. And depending on where we click, goes at different speeds. There's one problem. It's all upside down. Why? Well, in normal graphing, mathematically, the origin, aka point 00, is here where my mouse is. Bottom left corner. In computer graphics, at least PyGame, it's up here. The top left corner. Which happens to mean that everything gets flipped upside down. So to fix this, what we do is we transform our coordinates from bottom left to top left. And the way we do that is quite simple. We subtract the y-coordinate from the height of the window. Now our height of the window happens to be 500 pixels. We defined that here. So we just need to render, instead of at height, instead of drawing the cannonball at distance, comma, height, we need to draw it at distance, comma, 500 minus height. Save and run. And so we have physics. Now, you can use this physics engine that we've just described for any of your own games that require thrown objects, cannonballs, wet towels, as long as it doesn't require aerodynamics.